Welcome back, students. This is part 8, the last part, where we are going to solve two very important exercises. Let's start first with exercise number 4. In the figure below, line AD and CE intersect at B, and angle BCA of vertex C is equal to angle BED of vertex E. Show that angle BAC is equal to angle BDE question mark. So this is the only information given that is straightforward. The fact that these two lines AD and CE are intersecting, we can claim that angle ABC and angle EBD are vertically opposite angles. And of course, two vertically opposite angles are equal. In this exercise, we have no measurements given. So let's try to use the transitive property to prove that these two angles are equal. We know that in a triangle, the sum of the three angles is equal to 180 degrees. So we can claim that angle BAC is equal 180 degrees minus angle ACB plus angle ABC. Same in triangle EBD, we can claim that angle BDE is equal to 180 degrees minus angle DEB plus angle DBE. So let's start by writing these two calculation equations. Angle BAC is equal 180 degrees minus angle ACB plus CBA, triangle angle sum in ABC, and angle BDE is equal to 180 degrees minus angle EBD plus angle BED. Also triangle angle sum, but here in triangle EBD. So to prove that these two angles are equal, we need to prove that these two quantities are equal. So we need to prove that these two expressions are in fact equal. So let's compare each element in these two expressions and let's see if they are equal. First, of course, 180 and 180 are of course equal. No need to prove it. We know already that angle ACB or BCA is equal to angle BED. It's a straightforward evidence given. And angle CBA is equal to angle EBD because they are vertically opposite angles. So each element of these two expressions are equal respectively. So these two quantities are in fact equal. So since angle ACB is equal angle BED, it's given, and angle CBA is equal to angle EBD because vertically opposite angles are equal, result, these two angles are equal because they are equal to the same quantity. Result, angle BAC is equal to angle BED by transitivity. From this exercise, we can deduce a very important theorem that says if two angles in one triangle are equal to two angles in another triangle, then the third pair of angles are equal. It means the two remaining angles must be equal for sure. We proved it here by using the transitive property. So theorem, if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles are equal. Now let's use this theorem to show that these two angles are equal by using another method other than the transitive property. So here, since angle ACB is equal to angle BED, it's given, and since angle CAB is equal to angle EBD because they are vertically opposite angles, result, angle BAC and angle BDE, it means the third pair of angles, they must be equal. What is the reason here? It's because of the theorem. We can use the theorem instead of using the transitive property. Because if two angles of one triangle are equal to two angles of another triangle, then the third pair of angles are equal. This is a very important theorem that you can use in case you can prove that the two other angles in these two triangles are respectively equal. Now, a very important remark. In this exercise, the three angles of triangle ABC are respectively equal to the three angles of triangle EBD. But by looking at the side BA and BD, they are not equal. The side BC and BE, they are not equal. The side AC and ED, they are not equal. And looking at the shape of these two triangles, they are not the same, so these two triangles are not congruent. Although their three angles are respectively equal, but they are not congruent. So attention, if the three angles of one triangle are respectively equal to the three angles of another triangle, it doesn't mean that they are congruent. So be careful. We cannot prove that the two triangles are congruent by proving that their three angles are respectively equal. It's wrong. Let's remember the first case of congruence of two triangles. What is enough to prove that two triangles are congruent? We need three evidence, which are, so if we prove that one side and its two included angles from the first triangle are respectively equal to one side and its two included angles from the second triangle, in this case, we proved that these two triangles are congruent. Remember, first case of congruence. To prove that two triangles are congruent, we need to prove that one side and its two included angles from the first triangle are equal to one side and its two included angles from the second triangle. It means one side and its two adjacent angles, the two angles of vertices, the two extremities of this side are respectively equal to one side and the two adjacent angles of vertices, the two extremities of the sides of the second triangle. Now let's solve this last exercise, exercise 5, which is very important. In this adjacent figure, points R, P, and S are collinear, and point P is the midpoint of segment QT, and angle PQR is equal to angle PTS. So remark this information given about the fact that P is the midpoint of QT will allow us to claim that segment PQ is equal to segment PT, midpoint effect. We also have the second information that we can claim the fact that angle PQR equals angle PTS. It's a straightforward evidence. We need to show that P is the midpoint of SR. Remark, to show that point P is the midpoint of segment SR, we need to prove that segment PR is equal to segment PS, question mark. If we prove that these two segments are equal, it means as a result P is the midpoint of segment SR. Now let's see what work strategy we need to follow to prove that these two segments are equal. So first, we need to consider or choose two triangles where PR is the side of the first triangle and PS at the side of the second triangle. So here we notice that PR is a side of triangle PQR and PS is a side of triangle PST. Then we need to prove that these two triangles are congruent. After proving that they are congruent, we can claim that PR and PS are equal because they will be representing the corresponding elements of these two triangles and they must be equal. And as a result, we proved that P is the midpoint of SR. So here we notice that PR is a side of triangle PQR and PS is a side of triangle PST. So first, let's prove that triangles QPR and PST are congruent. So in triangles QPR and PST, let's gather the three evidence that we need to prove that they are congruent. So first, by looking at this evidence given, we can claim that PQ equals PT midpoint effect. All we need to do now is to prove that the two angles adjacent to QP are respectively equal to the two angles adjacent to PT. So first, the angle of vertex Q is equal to the angle of vertex T. So angle PQR equals PTS, it's given. Now we need to prove that the angles QPR and SPT are equal. Since points RP and S are collinear, and since P is the midpoint of QT, it means also that Q, P and T are also collinear points. It means that line QT and line ST, they intersect at P. That's why we can claim that these two angles are vertically opposite. So angle QPR and angle SPT are vertically opposite angles, and two vertically opposite angles are equal. So we found our three evidence. We found the fact that we have one side and its two included angles from this triangle QPR are respectively equal to one side and its included angles from triangle PST. So first, a segment PQ equals segment PT, and the reason is midpoint effect. Then angle PQR equals angle PTS. It's given, it's a straightforward evidence. And last, angle QPR equals angle SPT, vertically opposite angles are equal. So we proved that these two triangles are equal. Now, as a result, triangles QPR and PST are congruent by one equal side included between two equal angles. And after proving that these two triangles are congruent, we can claim that all their corresponding elements are equal. In particular, PR equals PS, or their corresponding elements must be equal. In particular, or namely, segment PR equals segment PS. And since these two segments are equal, it means a P is in fact their midpoint. Result, P is the midpoint of segment SR. So this is the end of this video. I would like you to redo these exercises by yourself. And then afterwards, we are ready now to start working the exercises in our book after remembering all the important strategies and properties that we will be needing later on. Thank you for watching.